Hello friends, we'll be talking about quadrilaterals in this session. So friends, let's first start with understanding what are quadrilaterals. We've already learned that in earlier classes that any closed figure which is formed by joining 4 points in an order is called quadrilateral. So a quadrilateral has 4 sides, 4 angles and 4 vertices. So we say that supposing we have these 4 points, we always say that we join the 4 points in an order to form a quadrilateral. So we join these 2 points, then join these 2 points, join these 2 points, and then join these 2 points, and that is where we get a quadrilateral. Now if we say that if we join this point and then this point and then this point and then this point, this will not be a quadrilateral. So it is important that the closed figure that we get by joining the 4 points in order is called quadrilateral. And then as we see that if we have any four-sided figure, any figure formed in this way, we'll have 4 sides, 4 vertices, and of course 4 angles associated with this figure. So these are some of the examples of a quadrilateral. So friends, now let's talk about the angle sum property of quadrilaterals. Now we know that a quadrilateral can be divided into 2 triangles. So this is a quadrilateral, and by drawing this line we have divided it into 2 triangles. Now by the angle sum property of a triangle, we know that the sum of angles of a triangle is always 180 degree, which would mean that if we take, say for example, we will first of all name this quadrilateral as ABCD, and now if we take the triangle ABC, we know that the sum of these 3 angles will be 180 degree by the angle sum property of the triangle. Now if we take the triangle ACD, we know that the sum of these 3 angles is also 180 degree because of the same angle sum property of triangle. Now if we want to find out the sum of angles of this quadrilateral, we can simply add all the angles of these 2 triangles, and that comes out to be 360 degree. So we can say that the sum of angles of a quadrilateral will always be 360 degrees. So this is the angle sum property of quadrilateral. So friends, just the way we found the sum of all the interior angles of a quadrilateral, we can similarly find out the sum of all the interior angles of an n-sided polygon. Now again, we divided a quadrilateral into 2 triangles. Now we can divide the polygons also into triangles. Now say for example, we take this figure. This is a 5-sided figure. Now if I divide this into triangles, we'll get 3 triangles in this figure. And this is not the only way to divide it into triangles. We could also draw it in a different way. We can also divide it like this. But again, we'll always get 3 triangles which make up this 5-sided figure. Similarly, if we have this figure, which is 1, 2, 3, 4, 5, 6, 7-sided figure, let's see how many triangles do we get in here. So this is 1, this is 2, this is 3, and this is 4. So we get 5 triangles in a 7-sided figure. So in the similar way, we can try for other n-sided polygons, and we'll see that the number of triangles which are formed is n minus 2. So the sum of the interior angles of any polygon will always be the sum of the angles of all these triangles added together. So if we talk about a five-sided figure and we have three triangles and we know that the sum of angles of each triangle is 180. So the sum of angles of this will be 540. Similarly, if we talk about the seven-sided figure, we are saying we get five triangles here and the sum of angles for each triangle is 180. So we get 900 as the sum here, sum of interior angles of this seven-sided polygon. So as we discussed, we get n minus 2 triangles and n minus 2, this is n minus 2 into 180. So this is the sum of the interior angles of an n-sided polygon, so which is given by n minus 2 into 180 degree. So friends, now let's talk about the different types of quadrilaterals that we have. So now there are certain quadrilaterals which have known properties. The basic definition of quadrilateral we know is it's a four-sided closed figure. So it has four sides, four vertices and four angles. But if there are quadrilaterals which have some known properties, they are the specific type of quadrilaterals and some specific names are given to them as per their characteristic properties. Now some of them are like rectangle, a square, a parallelogram, rhombus, kite, trapezium. So these are some of the specific quadrilaterals which have specific properties. And now we know that some of the quadrilaterals can actually fall in more than one of these categories. Now say for example we take a rectangle. Now this falls under rectangle as well as parallelogram. Now supposing we draw a square. Now it falls under rectangle, square, parallelogram, rhombus. So some of these figures will fall under more than one category. These are the different classifications of the quadrilaterals based on their specific characteristic properties that they exhibit. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.